The ongoing conflict between Ukraine and Russia has created a geopolitical tension marked by complex interactions and regional implications that has left both nations investing heavily in weaponry in the pursuit of military dominance. In an attempt to put an end to this tension, the United States has once again stepped in. Holding a prominent position in advanced weaponry, the United States has reaffirmed its support for Ukraine by deploying an advanced weapon, one that is extremely powerful and that Russia and China are terrified of. What are the unique capabilities of this weapon? Is it enough to change the outcome of the war? Join us as we delve into the capabilities of the new deadly U.S. missile that has terrified Russia and China. As a show of its support to Ukraine in its war with Russia, the United States has continuously supplied Ukraine with advanced weapons of warfare that would give it an edge against its rivals in the conflict. Weapons like anti-tank missiles, bombs, drones, and fighter jets have been deployed to Ukraine to assist with the war. In early February 2023, the U.S. announced a $2 billion aid package that they would supply Ukraine. The aid includes the ground-launched small-diameter bomb, a missile that Ukraine can launch from its existing HIMARS or MLRS launchers or from its own launcher. This missile has a longer range than what Ukraine had before, reaching 100 kilometers compared to the previous 85 km. This means Ukraine can now target Russian areas that were previously out of reach, including supply lines in eastern Ukraine and parts of Russian-occupied Crimea. It is a unique weapon system that uses an existing weapon and a stored rocket motor. The ground-launched, small-diameter bomb has never been used anywhere before and was tested for the first time in 2015. According to Saab, the glider that accompanies this weapon is designed to be challenging to intercept. It can be programmed to approach a target from various directions and angles, making it unpredictable. Unlike traditional artillery, the GLSDB's wings and navigation allow it to steer around obstacles and anti-air defenses, even coming from the target's rear. Being a glider, it has a minimal infrared signature, making it less susceptible to infrared homing missiles like man-pads. This marks the weapon's first export and combat use. Initially, it was estimated to take up to 9 months for a ground-launched version, but Boeing suggested it might be delivered as early as spring 2023. This weapon was developed by Boeing and the Saab Group to allow Boeing's GBU-39 small-diameter bomb to be ground-launched from several carriers. The GLSDB combines Boeing's invention with the M-26 rocket that enabled it to be launched from ground missiles like M142 HIMARS. In the early 2000s, the United States Army developed the GBU-39 SDB for stealth aircraft like the F-22 Raptor. Unfortunately, these aircraft cannot carry external weapons without compromising its invisibility, so the SDB was designed to fit internally. It is a compact bomb, only 7.5 inches in diameter and 59 feet long, with a weight of 286 pounds and 36 pounds of impact-resistant explosives. The bomb's unique design allows it to engage armored and fortified targets effectively. The bomb is guided by a combination of highly accurate satellite and inertial guidance. The SDB has high accuracy with a probable circular deviation of no more than 5 to 8 meters, and advanced versions further reduce this deviation to just 1 meter. First deployed in 2008, the GBU-39 SDB is now being replaced by the more advanced GBU-53 Stormbreaker. The Stormbreaker features a combined guidance system, including millimeter-active radar, semi-active laser, and passive infrared homing, enabling it to engage moving targets. This advancement marks a transition in military technology, enhancing the precision and capabilities of munitions for modern warfare. In February 2015, Boeing and Saab Group conducted several successful tests on the GLSDM. It offers 360-degree coverage, reaching targets behind mountains or circling back to the launch vehicle. With a 150 kilometers range and precision within 1 meter, It can detonate above ground or penetrate deeply with resilience to electronic warfare jamming. In a demonstration that took place in 2017, the ground-launched small-diameter bomb showed its capabilities by engaging a moving target from a distance of 100 kilometers. The small-diameter bomb and rocket motor separated at an altitude during the test, and the bomb used a semi-active laser seeker to track and engage the target. Subsequent tests in 2019 extended the range to 130 kilometers against a target at sea. Notably, the laser-guided SDB had already proven successful against targets moving at 50 miles per hour. While the exact cost of the GLSDB is undisclosed, the SDB used in it has a known cost of about $40 million to the U.S. military, and the accompanying M26 rocket comes from obsolete inventory. The overall cost of the GLSDB, including factors like the interstage adapter, launcher container development, and other associated costs from Boeing and Saab, remains unknown. For comparison, a single M31 missile is estimated at $500,000, and the U.S. Army is expected to pay about $168,000 for each GMLRS in 2023. The GLSDB is presented as a cost-effective long-distance alternative to the ATACMS missiles, which have a unit price well over $1 million. Another option is the Storm Shadow missiles with a 250-kilometer range, estimated to cost around €2 million in fiscal year 2023, and the UK has agreed to supply these to Ukraine. The primary objective in developing such weapons was to provide countries with limited resources the striking capability of more expensive and advanced air forces. In 2019, Boeing's Jim Leary, Director of Global Sales, emphasized that the GLSDB maximizes existing capabilities, creating opportunities for countries that lack a robust air force. The intention is to empower less affluent nations with effective strike capabilities, addressing security needs without the financial burden of maintaining a sophisticated air force. The ground-launched small-diameter bomb has a more localized impact compared to the GMLRs with its high-explosive warhead, but it proves highly effective against buildings and fortified structures. In tests, this bomb penetrated a 5-foot-thick aircraft shelter made of reinforced concrete. Although the GLSDB's flight speed is lower than the ballistic GMLRs, it gains advantages from a more intricate planning trajectory, lower flight altitude, maneuverability, and its smaller size, resulting in a compact, effective dispersion area of only 0.17 square feet. The weapon could be seen as a middle ground between the GMLRs and the MGM-140 ATACMS tactical missiles with a range of up to 185 miles. Remarkably, the GLSDB is cost-effective at only $40,000, considering the reuse of decommissioned aircraft bombs and nearly free rocket engines. In contrast, the GMLRS missile costs range from $100,000 to $160,000, and the ATACMS missile can go up to $2.3 million. The affordability of the GLSDB positions it as a strategic choice for nations seeking a balance between effective strike capability and cost efficiency, making it a valuable option for addressing security needs without the high expenses associated with other missile systems. On March 30, Taiwan delayed buying GLSDB at the United States' request, aiming to send it to Ukraine. The weapon is in the early production stage at 2023. The Taiwan Strait's narrowest part is within GLSDB range, making it harder for the PLA to assemble an invasion force. Laura Cooper informed Congress on June 22 that Ukraine would receive the ground-launched small-diameter bomb missiles no earlier than autumn due to delays. Boeing later stated on October 14 that GLSDB delivery to Ukraine would be by winter, but on November 30, reports surfaced that the delivery would be postponed to early 2024. The only downside to the GLSDB is that it is still a newly developed weapon, and the US has not yet had time to produce it in large numbers, But on the other hand, there's not much need to produce anything. Take the GBU-39 SDB bombs from the warehouse and the rocket engines for the M26 missile from another warehouse. Connect them, and the GLSDB is ready. Aside from the GLRBD, Ukraine has also shown interest in the F-18 Hornet. This weapon, similar to the GLRBD, is a versatile all-weather combat aircraft built for the U.S. Navy and Marine Corps. It serves as both a fighter and attack plane, designed by McDonnell Douglas and Northrop in the 1970s. The Hornet is utilized by various countries' air forces and was once part of the U.S. Navy's Blue Angels demonstration squadron. The FA-18 Hornet is a highly versatile aircraft designed with advanced avionics, cockpit displays, and excellent aerodynamics. It can carry a wide range of weapons, allowing it to perform various roles like fighter escort, fleet air defense, enemy air defense suppression, air interdiction, close air support, and aerial reconnaissance. While it's praised for its well-known and praised for its versatility and reliability on carriers, some naval aviation experts criticizes its limited range and payload compared to earlier aircraft like the Grumman F-14 Tomcat, Grumman A-6 Intruder, and LTV A-7 Corsair, two in specific roles such as fighter, strike fighter, and attack. The Hornet joined combat in the 1986 United States bombing of Libya and later played roles in the 1991 Gulf War and 2003 Iraq War. It laid the foundation for the Boeing FA-18EF Super Hornet, a larger, evolved version that replaced both the older Hornet and the F-14 Tomcat in the U.S. Navy. This fighter jet possesses exceptional maneuverability, is attributed to factors like a favorable thrust-to-weight ratio, a digital fly-by-wire control system, and leading-edge extensions that maintain control at high angles of attack. The wing, with a 20-degree sweep on the leading edge and a straight trailing edge, incorporates full-span leading-edge flaps and single-slotted flaps and ailerons along the trailing edge. Distinctive design elements, including canted vertical stabilizers, oversized horizontal stabilators, and flaperons, contribute to the Hornet's remarkable high angle of attack capabilities. Rigorous testing, notably with NASA's F-18 High Alpha research vehicle, showcased the Hornet's ability to handle high angles of attack up to 65 to 70 degrees using thrust vectoring vanes. NASA also utilized FA-18 stabilators as canards on the F-15S/MTD. The Hornet was at the forefront of adopting multi-function displays, allowing pilots to seamlessly switch between fighter and attack roles with the push of a button. This unique force multiplier feature enhances operational flexibility for commanders in rapidly changing battle scenarios. Notably, it became the first Navy aircraft to incorporate a digital multiplexing avionics bus, facilitating easy upgrades. Designed for reduced maintenance, the Hornet outperforms its heavier counterparts, the F-14 Tomcat and A-6 Intruder, with significantly less downtime. Its mean time between failures is 3 times greater than any other Navy strike aircraft, requiring only half the maintenance time. The innovative General Electric F404 engines prioritize operability, reliability, and maintainability. Although their rated performance may not be exceptional, these engines exhibit exceptional robustness under diverse conditions, displaying resistance to stall and flameout. Moreover, the F404 engine's unique design allows for straightforward replacement without special equipment. A 4-person team can remove and replace the engine within just 20 minutes. The Hornet achieves a top speed of Mach 1.8 at 40,000 feet. Ukraine also has one of the most powerful drones in its possession. The Bayraktar TB2 drone is a Turkish-made unmanned combat aerial vehicle designed for remote or autonomous flight. Manufactured by Baykar Makina, it's used by the Turkish Armed Forces. Controlled from the ground, it owes much of its development to Selçuk Bayraktar, a former MIT graduate student. As of November 2021, The TB2 drone accumulated 400,000 flight hours globally. Primarily used by the Turkish military, it was also exported to other nations. Turkey employed the drone in operations against PKK and YPG targets in Iraq and Syria. Various countries, including Azerbaijan, Ukraine, and Ethiopia, deployed Bayraktar drones in conflicts like the Second Nagorno-Karabakh War, the Russian invasion of Ukraine, and the Tigray War. The drone's widespread use showcases its impact on conflicts worldwide. The Bayraktar TB2 is designed with a distinctive blended wing body and inverted V-tail structure, featuring a variable pitch two-blade propeller for thrust. Its modular monocoque platform includes detachable parts like wings and tail components, predominantly made of carbon fiber composite. Fuel is stored in bladder tanks, with consumption balanced by solenoid valves. The ground control station follows NATO specifications, housed in a mobile unit supporting 3 personnel. It incorporates redundant systems, air conditioning, and NBC filtration. Operator interfaces include dual screens for real-time command, control, and monitoring. Despite the Turkish Armed Forces classifying it as tactical UAV class, international standards categorize the Bayraktar TB2 as a medium-altitude, long-endurance UAV. This distinction prevents it from directly competing with the Thai Anka UAV. The TB2 boasts a highly resilient flight control system featuring triple redundancy and autonomous capabilities for taxi, takeoff, cruise, landing, and parking. The computerized flight control system takes center stage, employing sensor fusion algorithms to process real-time sensor data. Mission-specific controls are managed by the Mission Control Computer System, while redundant rotary and linear servo actuators guide the aerial platform. Continuous development is dedicated to the main airborne avionics equipment, software, and hardware. Electronic power supply for onboard systems is fortified with triple alternators and balanced smart lithium-ion battery units. A robust heated camera in the tail monitor's flight, with all payload and telemetry data recorded to the airborne data recorder. The avionics redundancy architecture supports autonomous emergency landings on diverse airfields if needed. Utilizing sensor fusion algorithms, including an inertial navigation system, the TB2 ensures navigation and auto-landing capabilities, even in the absence of global positioning signals. This comprehensive system design enhances the TB2's autonomy, reliability, and adaptability in various operational scenarios. The estimated cost of a single Bayraktar TB2 unit stands at approximately $5 million. This valuation, although significantly lower than the US-built Reaper UAV, is noteworthy considering the TB2 carries only 1/10 of the payload in comparison. Despite Baykar not officially disclosing the price, their website showcases news reports on crowdfunding campaigns launched in Europe in 2022. These initiatives aim to secure Bayraktar UAVs for Ukraine and have set a collective goal of around $5.5 million per unit. This unconventional crowdfunding approach underlines the global interest and support for deploying Bayraktar TB2 in conflict zones, with various entities contributing to fund the acquisition of these unmanned aerial vehicles. The contrast between its cost-effectiveness and crowdfunding campaigns adds a unique dimension to the accessibility and international involvement surrounding the Bayraktar TB2 in modern warfare. The Ukrainian Air Force also has the advanced MiG-29 fighter jets in its possession. It is a twin-engine fighter aircraft that originated in the Soviet Union. Developed by the Mikoyan Design Bureau in the 1970s, it was designed as an air superiority fighter to counter new U.S. aircraft like the McDonnell Douglas F-15 Eagle and General Dynamics F-16 Fighting Falcon. The MiG-20 entered service with the Soviet Air Forces in 1983. While initially focused on air-to-air combat, many MiG-29s have been adapted as multi-role fighters capable of diverse operations and equipped with air-to-surface armaments. Variants include the MiG-29M, MiG-29K, and the advanced Mikoyan MiG-35. The MiG-29 has gained popularity globally, with over 30 nations operating or having operated this versatile aircraft. Its legacy endures through continued service and its significant role in the evolution of fighter aviation. The MiG-29 has wings that sweep backward and upward, with extensions at the front edges. It also has tailplanes and 2 vertical fins with slats on the wing's front edges. The aircraft uses hydraulic controls and autopilot, but lacks a fly-by-wire system. Despite this, it's highly maneuverable, excelling in turns and maintaining stability. The structure is mainly aluminum with some composite materials, designed to withstand maneuvers up to 9 times the force of gravity. The controls have safety features to limit certain movements, but these limits can be turned off manually. The cockpit of the MiG-29 has a traditional center stick and left-hand throttle controls, with the pilot seated in a K-36DM ejection seat. The cockpit features conventional dials along with a head-up display and a Shell There UM helmet-mounted display, but it lacks HOTAS, or hands-on throttle and stick capability. The design emphasizes similarity to earlier Soviet aircraft like the MiG-23, focusing on ease of conversion rather than ergonomics. Despite this, the MiG-29 offers improved visibility compared to earlier Soviet jet fighters, thanks to its high-mounted bubble canopy. Upgraded versions introduce glass cockpits, equipped with modern liquid crystal multi-function displays and true HOTAS capabilities, enhancing the aircraft's overall functionality and aligning with contemporary avionics standards. The MiG-29 is also equipped with 2 Klimov RD-33 turbofan engines, each capable of producing 50 kilonewtons of dry thrust and 81.3 kilonewtons of afterburner. The intentional spacing between the engines creates lift, reducing wing loading and enhancing maneuverability. Air is drawn through variable intake ramps beneath the leading-edge extensions for high Mach speeds. These engines, with a short combustor, emit more noticeable smoke compared to their contemporaries. To facilitate rough field operations, the main air inlet can fully close, and the upper fuselage's auxiliary air inlet is used during takeoff, landing, and low-altitude flight to prevent debris ingestion. Louver on the LERX automatically open when intakes are closed. In the latest MiG-35 variant, dorsal louvers are removed, and mesh screens in the main intakes, similar to the Su-27 design, are adopted, eliminating the need for the previous dorsal louvers. Looking at the capabilities of the GLRDB alongside other weapons that are in the possession of the Ukrainian Air Force and how their capabilities can easily influence the outcome of the war, Russia does not stand a chance against the advanced weapons owned by Ukraine. Thanks for watching. While you're still here, click on the video appearing on your screen to watch another of our interesting videos. See you there.